Number 2, what we're going to see here is gas stoichiometry using the ideal gas law. Now, the ideal gas law gets used a lot in gas stoichiometry problems because in the ideal gas law, PV is equal to nRT, we have this bad boy right here, which is a number of moles. And so if we're doing gas stoichiometry using the coefficients of a balanced chemical equation, if we can't use volume to volume ratios, we want to use mole-to-mole ratios, right? So we want to use the coefficients of that balanced chemical equation one way or another, right? If we can use volumes, we can use volumes, but if not, we're going to need to use moles. And with regard to gases, the ideal gas law has an equation that, or is an equation that uses a number of moles. So we can use this to solve for moles when we're in a bind. Speaking of, a large cylinder of helium gas, such as that used to inflate balloons, has a volume of about 25.0 liters at 22 degrees Celsius and 5.6 atmospheres. Okay, so we have a volume, we have a temperature, even though it's in degrees Celsius, we have to change it to kelvins, and we have a pressure. Now, I know what R is, right? You guys need to have the value for R memorized, and so we'll be able to solve for N. Okay, we'll be able to solve for N. Now we have to rearrange the equation to solve for N, and that will look like PV over RT. So let's plug some stuff in and get this solved. So what's my pressure? 5.6 atmospheres. What's my volume? 25 liters. Now R is that value that I've memorized at this point, and you should too. Now my temperature was given to me in degrees Celsius, but this needs to be in kelvins, right? So I simply add 273. Okay, and it's actually super simple to do it in the calculator. Obviously, just take whatever is printed on that piece of paper, add 273. You got it, 295K. That's 295K. Kelvins cancel with kelvins. Atmospheres cancel with atmospheres. Liters with liters. This is a 1 over moles, which is the same as just having a value for moles. And let's calculate. Let's go 5.6 times 25 all over 0.0821 times 295. We come up with, let's see, I need 2 sig figs, right? That only has 2 sig figs, so my answer needs to have 2 sig figs. So let's go 5.8. 5.8 moles. Boom. B. What is the mass of helium calculated in part A, right? What's the mass of this? 5.8 moles. All right. Now we're talking about helium. So I can look at the periodic table and convert from moles of helium into grams of helium pretty darn easily. Now, looking at my periodic table, looks like for every 1 mole of helium, I have 4.0 grams of helium. Moles of helium cancel, so I'm only left with grams of helium. So let's calculate. 5.8 times 4. Let's see, I'm still doing 2 sig figs here, so I'm going to keep that to 23. 23 grams of helium in this volume, pressure, at this temperature. That many moles, using the molar mass, convert to grams of helium.